There are 328 million people in the United States. 48 million of them suffer from some degree of hearing loss. 96,000 of those people have cochlear implants. My name is Alice Hutt. I am team leader of Auris. This is Jenny. She specialized in software. Chaitanya, she specialized in data collection. Sabrina, she specialized in hardware. And Rita, she also specialized in hardware. A cochlear implant is a device for those who suffer from total hearing loss. There is a sound processor worn behind the ear which captures sound, then processes it into digital code. The processor then transmits this code through the coil on the outside of the patient's head to the implant. The implant then converts the digital code into electric impulses which get sent along the electrode array in the cochlea. Finally, the electrodes stimulate the hearing nerves which send impulses to the brain which get interpreted as sound. The issue we see is that cochlear implant users usually do not know the characteristics of the room which they walk into. With today's technology such as Alexa and Google Home, there should be a device that can monitor room acoustics and characteristics and transmit this data to the CI user before they walk into the room. That is exactly what we have attempted to create. Since January, my team and I have been researching and developing the Auris device. The first phase was research. We needed to truly understand the basics of CIs, sound coding strategies, sound processing strategies, and computational platforms. We researched, gathered knowledge, gathered data, and decided on the ReSpeaker and Raspberry Pi as our computational platform. Next, we connected the Pi and the ReSpeaker, created code that would capture the DBA of the room, and developed an Android app that reads this data from the Pi and will soon communicate this data to the CCI mobile device, which is a device that the PhD team that we've been working with has given us that they have been working on. Moving forward to Senior Design 2, our goals are to extract more features from our data and to create a model for the room to then use this model to train our Auris device. After this, we hope to create an external shell for the device that lets in sound but is resistant to the elements, and to also figure out a better power supply. Thank you so much. Do y'all have any questions?
Define room characteristics.
Yeah, that's what I was going to say.
Why is it important?
So room characteristics would be like the impulses in the room. If there's lots of tapping sounds, let's say you're in a classroom and right next door they're doing construction. Yeah, so that wouldn't be very good for a cochlear implant user because that would cause.
So that funnels it out. Is that what it does?
It would cause impulses in there, and I think it would hurt their.
Oh, okay.
Their
And what
ear.
kind of adjustment you do on the implant itself, like called volume adjustment or something like that?
So our device is just going to know the room characteristics, and it's going to transmit this, as I said, to an Android app that then transmits it to the CCI mobile device, which is a device that we don't really have any control over.
So you don't exactly know what is an objective at the CI device yet.
The objective?
What are you going to do with the measurement?
So is it going to mask it out? Or
Is it going to filter
Right.
it? Filter the sound?
Yeah. Yes.
Okay, that's what we need to know.
Yes.
How do you get the room characteristics? Use the impulse response, like to do the foray of the impulse response? How do you find out what the room's doing?
Yeah, so we're planning on using MFCC features basically to extract like different features, and we're gonna do it through Python, and yeah.
I mean, what's your generation source? What kind of signal do you generate to find out what's in the room? You just listen, or do you actually generate active sounds?
We listen.
Right.
You're not. Okay, you're not.
The device has.
So yeah, go ahead.
The device just listens. It's
Oh, you just
constantly
listen.
listening
Okay, so
and
you're
constantly.
not trying to do a impulse response to the room. You're just listening. What's going on? And then you try to filter it out.
Yes, it's listening
Exactly.
for impulses to filter them out.
Okay.
How different is this for those that already UTD works on the infant project near UT Southwestern? There's a big division that they make.
Oh, for the CI lab?
Right.
So they work, if you see the CCI mobile down there, that is what they have developed. We are basically saying that when this connects to the cochlear implant, they still don't really know. You kind of take it for granted. They don't realize like what they're walking into in a space in a room. So our device stays in the room. The device they have developed actually connects to the cochlear implant, and that's what they carry around. So that when they walk into the room, their device, the CCI mobile, connects to our Auris device, and then it transmits the room characteristics to that device.
So have you already implemented your performance metrics? Do you have the Auris device, the Wi-Fi connection to Android app?
Yes.
You've done this too?
Yes.
Okay.
So can you tell how much improvement your device has? I know it looks like the intelligence is built on the CCA mobile device or whatever, right? It's not, you don't have any control of the intelligence about the room characteristics, stuff like that, right? So how much improvement do you the interface has versus what's out there in the industry?
I don't think they're
We're not really sure exactly what's out there in the industry.
Yeah.
We're not really sure exactly how much our improves. But I'm not sure exactly that's the point.
Why would I buy yours versus what is out there?
So basically, as of right now, CI users don't have anything that can tell them what's going on in the room, you know? There's different frequencies, like high frequencies, that they have, like they're currently struggling with that. So our device basically is gonna do that for them. It's gonna let them know what they're going into, if that makes sense.
Yeah. Is there an
Right.
objective criteria for the success here, that you're certain amount of noise reduction of a certain type? Is there a way of measuring whether you've succeeded at the end of the second semester?
Well, eventually,
Yes.
once we do the model in the second semester and we actually train our device,
Mhm.
it's gonna be able to say whether we wanna, we haven't decided yet how we wanna characterize the room, whether it's
Right.
loud, noisy, if there's music in there. We're gonna decide that later on, once we actually talk to an actual CI user. But our success will be measured by how accurate that'll be from the rooms that we've already collected data from.
Yeah, I don't know if we actually mentioned, but we're using a Lena unit, and basically we already recorded different rooms, right? So once we train our model, we're gonna compare it to that, to make sure, you know, everything's going right, like, if you know.
Yeah, I would suggest another higher level goal is to how you're going to affect this person that has the problem, right?
Right.
In other words, what improvement are you gonna make for them? These are all kind of nice goals.
Right.
Kind of engineering goals, but there's a.
I mean, the
How do you measure
ultimate.
their improvement? How do you measure, do you test it beforehand and afterwards, get a measurement, you know, some kind of measurement plan, says we're gonna take this person, we're gonna put them in a room without
Right.
your help, and then put them in a room with your help and see what happens.
That's actually the goal for next semester. We're gonna talk to a CI user, and, you know, we're gonna see what characteristics to extract based on what their needs are.
Okay.
Right.